about finding rational zeros. Okay, what if it can't be factored by grouping or any other method? Well, there is the rational root theorem. Rational root, your book calls it the rational zero theorem. I like the rational root theorem because it's got the sorry. But basically you can use this process to find if there is a rational root. So if we have a polynomial function in the form of f of x equals a sub n times x to the nth power, that just means this is the leading coefficient all the way down to however many terms it has, all the way down to a sub 1 x to the first plus a sub 0, where this one's the constant. If it has integer coefficients, then every rational root of the function will have this form, p over q, where p can be found by the factors of the constant term, which is a sub 0, and q are found by the factors of the leading coefficient, which is a sub n. Okay, so using this, we can create a list of possible rational roots. So if it has a rational root, it would be one of those no matter what. Okay, and then we're going to use that to find these zeros. Okay, remember, roots, zeros, factors, x-intercepts, they're all very closely related. Roots and zeros, that term there is used interchangeably. Factors, if it's got a rational root, then it has a linear factor. Okay, x-intercepts, any of the factors, if you set those equal to 0, that's an x-intercept on the graph, and we'll get there when we graph. Okay, what are the possible rational roots? So we're just going to list the possible rational roots using the rational root theorem. Okay, so f of x equals 2x cubed plus 3x squared minus 11x minus 6. So your possible rational roots. So your possible rational roots are going to look like p over q. Okay, where p are the factors of the constant term. You know, forget the negative. Just look at the 6. What are the factors of 6? And you also have to remember positives and negatives. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are all the factors of 6. Okay? And all of that's going to be divided by the factors of the leading coefficient, because that's q. Well, that's just 2 plus or minus 1 or plus or minus 2. Okay? We're going to do an example in a little bit that has 48 for the leading coefficient. That's going to be fun. Okay? But all the rational roots, so if 1 is the denominator, then all your possible rational roots are going to be 1 over 1, 2 over 1, 3 over 1, 6 over 1. Oh, okay. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. That's when I take each one of these over 1. Okay? Now we're going to take each one of these numerators over 2. Well, okay, 1 over 2. Oh, okay, so that's plus or minus 1/2. 2 over 2. That's 1. I already got that over here. 3 over 2. Okay, so that's plus or minus 3/2. And 6 over 2. Oh, 6 over 2, that's 3. Look, I already have that one. Don't need to write it again. So, for this function, all your possible rational roots are here. Alright, so now we're going to use it to find the actual zeros or roots of this function. What's nice is your leading coefficient is 1. If your leading coefficient is 1, then your possible rational roots are just going to be the factors of this. So that's where you start. Okay, you start by listing possible rational roots. All right, so I'm going to list them here. What are the factors of 18? Well, we got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Okay? So these are all our possible rational roots. Am I going to test every single one of those to find the rational roots? No. I'm going to test a few of them systematically and find one. Okay? Because to find the zeros, all you have to do, actually, if you can get this down to a quadratic, so if you can divide and get this to a quadratic, quadratics sometimes factor, or you can use quadratic formula. You know, you got many, many different ways you can solve that. Because remember, zeros are solutions. All right, so let's start with synthetic division. Okay, I usually will do a modified version of it, but for today, I guess not. I'm going to start with 1. Okay, so start systematically trying to find them. And I like to deal with 1 first, so I'm going to try to divide by 1. Okay, so I've got, let's see, 1, negative 4, negative 15, and 18. And if 1 is a root or a 0, the remainder is going to be 0. Makes sense, right? Right. All right, so 1 times 1 is 1, add negative 3. Negative 3 times 1 is negative 3, add negative 18. Negative 8, oh, looky there. How convenient is that? Definitely it is a 0. Okay, so technically we've done the synthetic division, so we've divided. So this is actually, I've got 1 is a 0, so I'm going to just list my zeros over here. 1 is a 0. Done. Now if this is x squared minus 3 minus 18, if I set that equal to 0, does that factor, are there factors of 18 that will subtract to 3? Well, here's your factors. 6 and 3. All right, so we've got x minus 6 and x plus 3 equals 0. Set each one of these factors equal to 0. It's part of solving. Finding the 0 is the same thing as solving. So x equals 6 and x equals negative 3. So these two are my other two zeros. I've got negative 3 and 6. Okay, third degree polynomial. Oh, it had 3 zeros. Okay, next one. Finding all the zeros again. List your possibles. Plus or minus 1. Thank goodness this is a 1. Plus or minus 2, plus or minus 7, plus or minus 14. Okay, those are my possible rational zeros or roots. Do synthetic division. Okay, starting with 1. Okay, synthetic division starting with 1. We're going to have 1, negative 8, 5, and 14. Bring down the 1. Do the math. We've got 1 times 1 is 1. This is negative 7. Negative 7 times 1 is negative 7. Add negative 2. Negative 2 times 1 is negative 2. This is 12. Okay? So we have a remainder. Since I have a remainder, that is not my 0. So I'm going to grab my eraser, which you guys could just rewrite it out. Write out another one. But I'm just going to erase, and I'm like, okay, what's the next one to do systematically? Well, I tried positive 1. Let's try negative 1. Honestly, I have them worked out. So later on, I'm going to skip a few. 1 times negative 1 is negative 1. This is negative 9. So this is positive 9. This is 14. This is negative 14. Oh, looky there. That one is 0. Okay, so for our zeros, I've got negative 1. Next one, this is x squared minus 9x plus 14. Set that equal to 0. And factor. Factors of 14, that'll add to 9. Oh, x minus 2, x minus 7. Both of these have to be minus because the middle term is subtracted and the third term is being added. Set each one of those equal to 0, x equals 2, and x equals 7. So there's your other two zeros.